Imagine you're packing a bag for a trip, limited space, but many valuable items to choose from. What do you pick? This classic dilemma is exactly what the knapsack problem is all about. And today, we're diving into how greedy algorithms help and sometimes fail to solve it. Stay tuned because the difference could save your algorithm or break it. Welcome to EduAIverse, where computer science becomes crystal clear. In today's video, we'll explore the knapsack problem, learn the difference between 0, 1 and fractional knapsack, and understand why the greedy approach works in one and fails in the other. No coding experience needed, just curiosity. What is the knapsack problem? The knapsack problem is a popular optimization challenge. You have a knapsack with limited capacity. You must choose items with given weights and values. The goal: maximize total value without exceeding the capacity. Types of knapsack. Problems. 1. 0, 1, 1 knapsack problem. You either take the entire item or leave it. No fractions allowed. Example, a laptop or a phone. You can't take just a piece of it. 2. Fractional knapsack problem. You can take parts of an item. Example, filling your bag with grains or liquid can take half or quarter amounts. Why greedy doesn't work for 0-1 knapsack. In 0-1 knapsack, making the locally best choice doesn't always lead to the best result. Example, item A, value, 100, weight, on a 20. Item B, value, on 60, weight, on a 10. Greedy might pick A, but B plus another small item might give a better total value. Conclusion: 0-1 knapsack needs dynamic programming for optimal results. Fractional knapsack, greedy strategy. Here, the greedy approach works perfectly because you can take parts of items. Strategy: calculate value-weight ratio for all items. Sort items based on this ratio in descending order. Pick the item with the highest ratio first, filling the knapsack partially if needed. Example: item A, 60 value, 10 weight, ratio, over 6. Item B, 100 value, 20 weight, ratio, over 5. Pick A first, then B. Time complexity. Analysis: 1. Fractional knapsack, greedy. Sorting, addition, O(n) log n. 2. Greedy selection, O(n). Total, O(n) log n. 0-1 knapsack, dynamic programming. O(n) x W, where W shunder knapsack capacity, slower but accurate conclusion. The knapsack problem teaches us a key lesson: greedy is not always good. Use the greedy approach for fractional knapsack, but trust dynamic programming for 0-1 knapsack. Understanding the type of problem you're solving is the real key to algorithmic success. If this video helped you understand the knapsack problem and greedy algorithms, give it a like, drop your thoughts or questions in the comments, and don't forget to subscribe to EduAIverse. Hit the bell icon for more videos that simplify computer science concepts.